My name is Nikos Xavidis. I'm a professor of statistics here at the University of Southampton, and I have been working on small area estimation for a long time. Currently still working on small area estimation in terms of research interests, but also in terms of delivering similar training in other parts of the world and internally within Southampton. Similar courses have taken place. So that's who I am. I'm happy to provide more details if you have questions about myself. And I'm going to hand over to my colleague, Angela Luna, to introduce herself now. Angela.
Thank you. My name is Angela Luna. I'm a lecturer at the Department of Social Statistics and Demography at the University of Southampton as well. I am a former DANE worker for many years. I worked on DANE from 2001 until the end of 2009, when I left to work to do my master's first in Brazil, and then I came to Southampton to do my PhD working on small area estimation. And then after finishing my PhD working on small area estimation, I just stayed here working as a lecturer as well. I do research on small area estimation. I'm very interested in poverty mapping as well, and I'm extremely happy to be able to take part on this course. Clearly, I'm also Spanish speaking, so if you have any troubles, any additional questions, I'm very happy to talk about that as well. That's basically it. Thanks.
Fantastic. And you have the advantage that you can communicate with Angela in your mother tongue. So that's an additional benefit if you have any questions that require a lot more careful description. So what I'm going to do now is I'm going to take you a bit through the code. We're going to give a very brief introduction to the course and the presenters, which we have already done. And then we're going to give an introduction to the problem of small area estimation. And this first week will focus quite a lot, the first 3 days will focus quite a lot on design-based inference, a framework which is called design-based inference. And why we do that is because this training is delivered for colleagues in DANE. And DANE is a National Statistical Institute, and design-based frameworks have been really the workhorse for decades within National Statistical Office. So I think that a design-based framework provides the foundations for small area estimation. You cannot really do small area estimation unless you have a firm understanding of the framework that we're going to present during this first week of the course. And that will become apparent as we go through the more advanced techniques later on that use models, because all the time we're going to refer back to design-based estimates, like the direct estimates of parameters of interest, and even for validation purposes, so for purposes basically of deciding whether your estimates are of acceptable quality in some respects, the direct estimates and design-based estimates will be forming the foundations for those kind of comparisons. And the reason for that is that the properties of design-based estimators are well known, and they are in most cases they have properties that are very desirable from the point of view of a National Statistical Office. And I keep referring back to the fact that DANE is a National Statistical Office, right? So you are governed by, I suspect you're governed by quality assurance protocols. And your estimates need to be accompanied by quality measures, for example, precision and coefficients of variation and so on. So in this part, we will cover simple statistics like totals and means, and we will talk a lot about direct and indirect domain estimation. And Angela has prepared notes on these methods, and it will include ideas around GREC, generalized regression estimators, and calibration estimators. And then she will also talk about synthetic and composite estimators, which are really, really important for moving on to the model-based methods later on, because you will see that model-based estimators effectively become like composite estimators with particular weights that we will apply there. So Angela will cover all this foundation stuff, and then she will talk about an important aspect, which is basically variance estimation. And so we'll cover things around generalized variance functions and so on. This is also very important because a set of design-based estimators might be, or model-assisted estimators might be a starting point in the production of any poverty assessment or any small area estimation. And we will have to assess at some point whether this set of estimators are sufficient. In many cases, they are not sufficient. But if they are sufficient for the purpose of what you're trying to do, that will be a good thing, because the office may decide to use this set of estimates. At the end of this week, there will be a lab in R, and that will cover the theory that was described during the theory parts of the course, and that will be on design-based domain estimation. So let me say something about the labs. The labs is a set of instructions that use existing data sets, and the idea is basically to allow you to implement some of the methods that you come across in the theoretical session in a practical framework. So they're quite quick to implement, and because of the distance that we're having, because this training is delivered online, what we're going to do is we're going to go quickly through the different parts of the computer lab, Angela or I, depending on who is organizing the corresponding lab. And we're going to show you the set of commands. And then what we will expect from you is two things. One is to replicate the lab as it is yourself, so that you become familiar with the methods. And then there is a second part, which is basically translating the lab into data that are available in Dane. Ideally, what we want you to do as we go through the training is for you to use some data from Dane, the data that you are already using, to implement similar ideas, similar operations as the ones that we will cover in the computer labs. Okay, so this is about week one. Then arriving on Friday, depending on how quickly we go, we may take the entire 3 days this week to cover the first part of the course, or we may have a bit of time to kickstart what we call model-based methods. And here we're going to cover model-based methods 1, and that will be on area level models. Okay, so here we're going to give you an introduction to a set of models that have been used quite heavily in the production of small area statistics using the Fay-Harriott model. We're going to present ideas around the use of best linear unbiased predictors and empirical best linear unbiased predictors. And very importantly, we're going to cover in all the methods, again, the assessment of uncertainty. And here we will start talking about mean squared error estimation. As I said, every time you produce a set of point estimates, you will need to accompany that with a set of estimated uncertainties, normally captured either via a design variance or via a mean squared error estimator. And here we're going to cover analytic methods, because analytic estimators for mean squared error are available in certain cases, and also bootstrap methods that are becoming increasingly important as we move to producing more complex statistics. We're going to cover prediction for out-of-sample areas, because it may be in the case of Dane that the municipalities that we're going to work with in your data may not be all of them available in your sample data. So we'll talk a bit about how do you predict for areas that have no representation in your sample data set. And then we're going to cover another set of topics that were specified in the spec by the United Nations. That will include a discussion around benchmarking and the use of generalized linear functions in the Fay-Harriott model. We're going to briefly cover a bit on Bayesian estimation in case some of you are interested in implementing a Bayesian approach to fitting this model. And it comes with certain advantages in terms of producing uncertainty measures by using the posterior distribution. Then we have one example of an extension of the area level model to include specially correlated random effects. We have a topic on use of transformations. In particular, we're going to focus on an example here where we're modeling proportions, and proportions might be relevant in the case of poverty mapping if you model directly the proportion of poor households or poor people. And we're going to use the arc-sine transformation, which is a popular one in the case of modeling proportions. And then we have an extension that includes a Fay-Harriott model with covariate measurement error. And the reason for that, as you will discover a bit later, is because from what we looked into your data sources, you have multiple data sources, and some of them may be associated with some uncertainty, and so that extension might give you another tool that might be of interest for operations within DANE. And we will illustrate all of these methods using the EMDI package. So one of the key tools that we're going to use is the EMDI package, that is an R package that implements a lot of these methods automatically. We have here a case study around poverty mapping and with use of remote sensing data. And then that will have a second lab, again, specifically focusing on the Fay-Harriott model. And then once we do that, then we're going to move to unit level models. And we're going to cover the standard Matisse, Harter, and Fuller model, which is based on unit level data, including BLAP and EBLAP estimation and mean squared error estimation. And then we're going to move to methods for poverty mapping. We are going to review again the ELL method that has been used quite a lot by the World Bank, and I'm pretty sure that some of you may be familiar with the method. And then we're going to focus mainly on the EBP method, the empirical best prediction method for poverty mapping, and talk about mean squared error estimation. And at that point, we're going to give you a set of tools, of ideas about how the EBP can be extended and how it can be modified in order to become a bit more realistic when it comes to real applications. And we're going to focus in particular on the use of transformations, which is one way of a very popular way of implementing models for poverty mapping using income or consumption type data. Again, EMDI will be used to illustrate the poverty mapping methods and examples. And we're going to have a third lab focusing specifically on unit level methods. Okay. And then the final session will be, session 4 will be on a framework for producing small area estimates. And there we're going to cover also topics around dissemination and communication of the estimates, as was requested by colleagues. And we're going to cover things around, as we go through the course, around model selection and comparing the estimates with the other, validating the estimates effectively that you get. And then what we want to conclude with is basically we want to have some DANE case studies and technical support. So effectively, as we go through the course, and in particular as part of the discussions around the computer labs, what we would like from you is to then start translating these materials into DANE, and then we're going to be there to help you to try to get going with implementing some of the methods and having an output that will be useful for you. Okay. That was quite a bit of discussion around the timetable. One thing I wanted to say before I turn to Angela and ask her to add or say a few things is effectively that clearly this is a vast literature, and we're not going to be covering every method. However, the methods that we're going to present are methods that are generally accepted by international organizations such as the World Bank and so on as methods that are in current use for small area estimation and poverty mapping. So that's the first thing. The second thing is that we're going to give you foundations for these methods. So we're not going to jump into the methods, say, to describe the EBP without describing a bit of what BLAP and EBLAP and about direct estimation and design-based frameworks. Okay, so you will get a firm grounding into the methods, and this is a set of building blocks that will lead up to making some applications using model-based methods. Now, more recently, we have come across, and certainly in our work, we start working with these types of methods. more algorithmic type methods that rely on machine learning type ideas. And so I would say that one of the key issues with more algorithmic methods is that the ideas around producing estimates of uncertainty has not been resolved completely. And so it's one thing is to use an algorithm to produce a set of estimates, and the other thing is to use an algorithm to produce a set of estimates that can be used potentially as national statistics or as a way of communicating and informing policy. So we are happy to discuss things around other algorithmic type methods that are not part of the training formally, but you may have an interest in. And we're happy to give you our views on those. And as I said, at the moment I'm involved in a project on the use of random forests, for example, to try and improve prediction and so on. But I would say that if your interest is basically on producing estimates that can inform national and local policies, I think the training we will provide as part of this course will take you quite far in terms of producing these estimates, okay? I'm going to finish here. The only thing I would like to plea with you is that you cooperate and you start forming these ideas with your dataset so that we can see how applicable these methods are to DANE. Okay, I'm going to stop here. Angela, do you want to say something?
I guess the only thing that I would like to add on top of the things that you have said is that I'm sure you can see it, or that this is a very, very vast amount of literature, and that means that we're trying to give you a general overview of the whole set of tools that you could use for a particular problem that's applicable to poverty, but is also applicable for many other things. But because of the amount, the big amount of content that we need to cover, we are not going to go perhaps in the level of technical detail as other courses go. So for instance, here in Southampton, we have a course on small area estimation where we do the proofs of each one of the things, who's unbiased, who's not unbiased, how do you develop the mean square error estimator for this particular method. We're not going to go through that very, very, very deep level of mathematical and technical detail because we don't have the time. But we're happy to suggest you to guide you to the relevant sources if you're interested on the more detailed proofs of those things. The course has the idea of give you a very general overview and a set of tools that you can use. It's more a practical course than a theoretical course in that sense. However, we do appreciate the need for you to have the relevant information so that you can make a decision. Because bottom line, what you have is a set of different techniques, and you're going to have to find out which one is the one that is more useful for a particular problem that you have. And for that, we think you need to have the whole story, to be told the whole story. I think that's the only thing that I would add, Nikos.
Fantastic. That helps us a lot. Thank you.
I'm going to start today by trying to motivate you to the problem of small area estimation. So I'm sure you have been discussing this issue internally about the particular needs that you have. Poverty mapping is one of the big things that most countries have a need to produce. But I would like to spend some time now to just describe the whole situation, try to broaden a bit your horizon in that sense. And I would be very happy if at the end of this section, this whole first section of material that I should present to you during this week, if at the end of this you have a better understanding of the problem, that for me it's already a successful thing. Okay. So let me start by introducing you to the problem of small area estimation. This is a classic problem. Everybody now is very interested in producing highly disaggregated estimates for many types of phenomenon. We are in a situation where politicians and everybody else wants to make decisions at local levels, and in order to formulate policy and make decisions at local levels for policy planning, for monitoring of socioeconomic conditions, for allocation of government funds, we need local information. And unfortunately, providing local information is something that is generally very expensive and difficult to do. So we're going to start now by discussing what are the tools that we have to produce this type of local information that would be able to help us with local planning. So I'm going to start talking about two particular issues. The first one is what are the data sources that are available, and the second one is which one is the framework of inference that you would like to work in. Okay. So I'm interested particularly on you being able to help me to understand what are the data sources available, because at the end of this course, we are planning to keep providing support for DANE. So it's very useful for us to get an understanding of what are the data that you have. I knew what data that DANE had 10 years ago. I don't know that anymore. So it would be very, very useful if you can jump in and make comments and interact with me in this section. So I'm going to start by describing that, and then I'm going to talk about the framework of inference, focusing on the two main frameworks that Nikos described before, the design-based framework, and then I'm going to talk about the model-based framework. How are they similar? How are they different? I was very interested in knowing what is your background, because I'm not sure this is a discussion that is very often given in economics courses. It's a discussion that happens in statistics courses, but not often in economics courses. So I would like to see how can I handle this discussion with you. There is also a third framework of inference that he mentioned, the algorithmic framework of inference, and I will say just a couple of things about that. Okay, so let's start by the data sources. So usually at a national statistical institute, you would have three main types of data sources. You would have sampling surveys, you would have population censuses, and you would have some level of administrative data or other types of data sources. So I'm going to start by talking about sampling surveys, which are still the main data source in developing countries. I'm talking about developing countries, and there are developing countries and developing countries. Developed countries are generally much more focused on developing administrative data records. Places like countries in Scandinavia, like Norway, Finland, are very focused on building systems of administrative data that allow them to have an up-to-date view of the population at any point in time. Whereas developing countries generally rely more on sampling surveys. Why are sampling surveys an important piece of that data ecosystem in developing countries? Fundamentally, because of two things. One thing is because those are sources where the questionnaire content and the target population can be tailored to the study needs. So if you want to measure poverty, then you can develop a survey that addresses exactly or as close as possible the population that you want to access, and you can decide how you want to measure that phenomenon. How do you want to define poverty, or how do you want to define income? You can tailor the content of your questionnaire to measure income in the way how you would like to define the phenomenon. That's one of the advantages of having sampling surveys, and one of the reasons why they are still so popular in the case of developing countries. The second reason is because sampling surveys usually are analyzed under the randomization or design-based framework of inference. I'm going to talk a bit more about that a little bit later, but the basic idea is that it's a very, very flexible, very it's not simple, but it's a very flexible framework of inference that is based on a very limited number of assumptions. And the fact that you don't have to assume many things is generally seen as a good thing in the context of official statistics, because you are making less assumptions that you need to prove less things, let's say. So the fact that you can get good estimates of good quality for the parameters of interest while having almost no assumption, is an almost assumption-free framework of inference, is something that is desirable in the context of official statistics. Okay, so those are two very good things about sampling surveys, but there are drawbacks as well. The two main drawbacks for the case of sampling surveys are: the first one, high cost and effort, because the National Statistical Office, is typically who will collect that data, and collecting that data is very expensive. So you can do it in person, like many of the surveys in DANE, I presume, are still done in person. You can do that online, you can do it on the phone, you can do it on paper, but it still is something that requires a very big amount of effort, and it is relatively expensive as an operation. Because of that, we end up being limited in terms of the sample size. We end up having a big limitation in the number of people, or the number of households, or the number of enterprises that we can visit. And because of that, because of the small sample sizes, providing precise estimates, particularly for small domains of interest, is problematic. So I'm going to talk a bit more about the issue of estimation in domains, what is called planned domains and unplanned domains. But let's say that in general, the problem of having small sample sizes is a problem in general in survey samples, but is even more of a problem in the case of trying to produce small area estimates. Finally, the second drawback that I mentioned for sampling surveys is that they're particularly problematic for the estimation of rare phenomena and out of sample areas. And those two things are related again with the fact that we're limited by the sample size. So if we have just a certain number of surveys that we can implement on the field, then we may end up, in the case of wanting estimates for small domains, in a situation where phenomena that are rare, populations that are rare ethnic groups, or a population, people in the population that has a particular rare characteristic, disabled people, for example, or very old people, it may not be ideal to try to address them using a survey, because you may end up in a situation where you don't see anyone in your sample, for example. So that is a problem for studying rare phenomena. And because of the way how samples are collected, generally you don't have sampled in all the areas you would be interested to have. So that brings us to the issue of out of sample areas, and how can you produce an estimate for, let's say, the poverty in the city of, I don't know, Florencia, Caquetá, if you have never been to Florencia, Caquetá. So how are you going to obtain an estimate under this framework of inference for that particular case is problematic. Okay, so that in terms of sampling surveys. We also have, as additional tools, we have population censuses, and population censuses tend to be, particularly in developing countries, the gold standard for data. They, at least in theory, offer full coverage of the population, meaning the only thing that you need in terms of inference is to sum, count, generate a table. You don't need to perform any additional processing. And because they cover the whole population, then high level of disaggregations are possible. So that may be, for example, having a census data may be the only chance that we have to make a very accurate description of rare groups. Again, I'm thinking on something like people with a particular disability, or people from a particular ethnic group. It's going to be very difficult to describe this type of populations using surveys, but we can do that using population censuses. However, if we think that surveys are expensive, then censuses are much more expensive. It's not exclusively in Colombia, but generally the census is the most expensive operation that any national statistical institute can perform. The census year is where everybody's budgets go up high. Those operations are very costly and therefore end up being very infrequently done. In places like in developing countries, they tend to take place every 10 years. In Colombia, I'm aware that it's 10, 12, 15, something like that. It's not as straightforward. In other countries, they can take place like one big census every 10 years and maybe something like a middle count with a very short questionnaire every 5 years, for example, just to keep things a bit rolling. There has been a whole set of research in the last 10 years about how to improve censuses to make them more frequent and less expensive, but that's not the topic of this talk. In general, population censuses tend to be costly and infrequent, so they're very useful to set up baselines whenever we can measure those things at the census year, but they're not very useful for follow-up. The other drawback that population censuses have is exactly because of the problem of cost there is a limitation, there is a big limitation in terms of the quantity and the type of things that you want to ask in a population census. So things like income, for instance, is very rarely asked in a census questionnaire, although it would be the perfect measure, the perfect variable that you would want to collect if you want to produce a poverty mapping. If you wanted to produce poverty maps and you had the chance of collecting income in the census, then for that census year at least, you could be able to produce those maps at the level of resolution that you would want it. Now, can anybody tell me why we don't pick up income, why we don't collect income in the census? Have you ever wondered why? Do you have any idea of why that doesn't happen often?
I think that maybe the reason is the low frequency of data, and because it is already collected in the sample survey, so we cannot, we should not ask the question twice.
Okay, thank you so much. Yes, okay, that sounds all right, but we do ask a lot of things twice. We ask sex, we ask age, we ask marital status. Basically, all the things that you have in a census, you also ask them in the surveys. It's just that you want, in the case of the census, you have the chance, the rare chance of seeing the whole population. So you want to set up the structure of the population. You want to see the whole structure of the population in the census year. So yes, it is true. We try not to ask the same thing twice because that just is burden for the respondent. But that's not necessarily the reason why we don't ask income as a particular variable in the census. Anybody else?
I really don't know. Maybe it is because there is not the purpose of the census recollection data. And I don't know if it is because this is información sensible at the sense that are you asking the exactly amount that they receive to all the population? So I don't know if this some ethical or moral problems with the recollection of the data.
Thank you so much. Thanks, Santiago. That's a very good point. Yes. So actually, the reasons that I'm aware of why we don't ask income in the census are in that sense. One of them is because asking income is actually something that is very complicated. You work on the poverty groups. You may know already that you cannot just put a question in your questionnaire that says, "Oh, how much was your income last year?" Because people doesn't know that. So you need a battery of questions in order to be able to build a measure of income that has some level of reliability. And that may mean what? 5 questions, 7 questions, 10 questions. You need to know if people is employed or unemployed, they have rents, if they have, I don't know, bonds. There may be so many different sources of income that including income in the census would make that questionnaire relatively large. And because census is something that is very expensive, you cannot really afford to ask all those questions. Okay? Even if you think about employment, for example, the way how we ask employment in the LFS, in the labor force survey, or the way how we ask employment on the census are completely different. Because in the labor force survey, you can afford to have 4 or 5 questions to actually filter who's employed and who's not. And in the census, you have 1 or 2, that's it. You cannot afford to ask many more than that. So that is one of the reasons why we don't ask income. But the other reason why we don't ask income in the census is because you try to avoid in the census anything that can make problematic your response. So if people is going to say, "Oh, you know what? I don't want to answer this," you're taking the risk of making a very big statistical operation that's going to end up with a high level of non-response, which is clearly not ideal. So these kind of things you have to be very careful, and this is one of the reasons why income is, I think there is one country, I saw it once, where they collected income in the census. But besides that, nobody asked income in the census, although everybody would be very happy if you could have at least once every 10 years a measure of income for the whole population. Okay? So things, that is the second drawback that I'm talking about population censuses. You can get level the disaggregate the variables at the level, geographic level that you would like them. But in terms of topics, there are certain topics that you can't ask, or that you cannot ask in the level of depth that you would like to ask them. Okay? In particular, census do not collect income. Then we go to another type of data sources. We can talk about administrative data, and we can talk about other data sources. I would say the main of which at this point in time is basically remote sensing data. So let me start by talking about administrative data first. Administrative data is data that has been generally collected or generated. Sometimes it's just generated automatically, so I wouldn't say that it was collected, but that is collected or generated for other purposes than the study. So you are going to reuse data that has been collected for a different purpose. You're going to use data that not necessarily belongs to the National Statistical Office, that doesn't belong to DANE, but certainly is going to become to the Minister of Health or any other DIAN or any other organization. And then, yes, okay, perhaps for different purposes than the study and perhaps by a different agency. Administrative data is something that it has an increasing relevance for official statistics because it has many advantages. So, for example, administrative data tends to have high coverage for the specific part of the population that is of interest for that, let's say, that agency. So, for example, if you talk about tax information, it's going to have very high coverage for the piece of the population that the tax office is interested in, and probably zero coverage for anything that is outside. Is that administrative data have high frequency. Generally, you have things like taxes, you have them yearly, and so on. Is low cost, is information that is low cost to collect because it has already been collected for different purposes, but it's already available. And at least in theory, it has low respondent burden. You don't have to go back to the source again and ask them again and again and again the same information. They have already provided, so being able to reuse it instead of having to ask it twice, it's indeed something that is very good. Now, drawbacks in terms of administrative data are that the target populations and definitions cannot be tailored to the study needs. So, for example, if you're going to use data that has been, like in the case of the UK, for unemployment, for example, you could use data that involves people that receives unemployment benefit. Okay, but then is that your definition of what an unemployed person is? You may have many other people that is unemployed but do not have the right to receive unemployment benefit. So in that sense, that target population, your target population, is different from the target population of the agency that distributes that benefit. So there can be mismatches in that sense, and there is nothing you can do because you're not the owner of that data set. In the same sense, whatever the definition of not only the population, but the definition of the phenomenon as such may be different, maybe something that is set by a foreign agency. If relationships between the agencies are good, then maybe you can try to do something about tailoring it a little bit closer to your needs. But bottom line is not necessarily the data that is collected by the National Statistical Office. And then in that sense, it's limited the amount of control that you have for this type of data. Finally, if we think about something that is not administrative data, but for example, other data sources such as remote sensing data, then remote sensing data, what is remote sensing data? Is data that you can process, you can obtain from things like spatial imagery. So there is a satellite that is going all around, going over the globe, and is taking pictures of every piece of land on Earth constantly. And then you can take those images, process them, and after processing them, you can subtract certain pieces of information. So you can check, for example, how illuminated a particular area is, how is the coverage in terms of cultures, or in terms of grass or water, rivers, things like that. You can see what are new developments of housing, for example. All these kind of things you should be able to read from that data after you have processed them. So it's similar to administrative data in the sense that is data that has been collected for other purposes. You may be able to extract some information from that, but you're not going to be able to obtain income from remote dating source, remote sensing data. You may get things that are correlated with income, but you're not going to get income. So you cannot necessarily collect everything that you need from this type of data sources. They cannot be tailored to the needs of your particular study. In terms of administrative data and alternative data sources, there are some countries where they are almost able to substitute surveys and censuses, but those cases are rare. So again, I'm talking about Norway, Finland, Sweden, that have extremely developed administrative data ecosystems where they can literally know who you are, where did you work, when was the last time that you went to the doctor. All that information is linked, so they have access to all those things, and then they don't really need to ask you again whether you're employed or not, because they have you in all those data sets. Besides those very rare cases of Scandinavian countries, in most places they are used because they're useful in combination with other sources, but they are not yet at the point of being able to replace surveys and censuses. Here in the UK, for example, when I first came here in 2012, there was a lot of discussion about the 2011 census that had just finished, and they were preparing for the 2021 census. And there was a big discussion about whether it would be possible to do an administrative-based census, something where they didn't have to send forms anywhere and could just put all the information together using the administrative sources that are available. And after many years of research, 2021 came, and the answer was no, we can't. So the census had a component online, a component in paper, whatever. There is still a lot of research in terms of doing a more combination of survey and census data with administrative sources, but administrative sources on its own are not there yet to replace censuses and survey. The last thing about these two type of data sources, censuses and administrative data, is that we say that they're great because they don't have sampling variance, but that doesn't mean that they don't have many other sampling errors. So the theory of dealing with these things, those of you that are working currently with administrative data would know it. There is no uncertainty in terms of sampling variance, but there are many other things that you have to be careful about. You have to take care about whether the data is up to date, whether half of the data is up to date and the other one will be updated next week, about lags on those on the information, non-response, gaps, if the data is filled by the own users, whether the data is actually of good quality or not. There are many other things that you need to check in terms of administrative sources that are not the standard things that we check with surveys, but that are as problematic as the other ones. Okay? So that is what I wanted to tell you in terms of data sources. So I would be very happy to stop here 1 minute and just try to hear from you, from those of you that are still around, what kind of data sources do you, if you can mention one of the data sources that you're working with, and how do you see that in the context of the things that I have just described? Tell me. Oh, it's Ticos. No, Jose de Jesus.
I have been working with Social Security administrative data, where we have, in fact, faced those challenges that were pointed by you, and we have worked with try to define better the target population, so we can filter out those units that are not of interest, those units that are not of statistical interest. And we have also worked with time references. I think that this is also a common challenge in administrative data. It is that we have like actualizations. I don't know. I'm not sure how to say this, but we have a number of figures today, and this figure is with the time we receive more information, more available information, that so we need to change that figure because there are more payments, that there are payments, lagged payments. So this is not a thing that usually happens in surveys, because in surveys we have like in the first publication or on the we have a figure, a number that is gonna be that is not gonna change that much with the time.
But thank you so much. That's extremely useful. Yes, I mean, I think the name that receives is revision. So, like for example, if you have tax data and tax year is closed, and then wait a second, they're revising this thing, and then you have already processed the figures, but after the revision, the figures change slightly, and that's just the nature of administrative data. Yes, it looks a bit more like what happens with national accounts, that nothing is definitive until like 3 years later, basically, in some cases. So yes, thank you very much. Thank you very much, Jose. I don't know in terms of surveys. I used to have a very good idea of which kind of surveys DANE had 10 years ago. I don't really know that anymore. So I don't know if anyone can step in a little bit thinking on poverty to tell us what are the main surveys that are collecting income at this point in DANE.
Hi. Here in DANE, we use the GRED survey, the GRED integrated survey of households that we use to estimate the incomes from the households, and in our estimations we take into account the non-response and the extreme values that we find in the survey, so we can estimate the income of households in a full way. And we use different sources of income. For example, first activity, or income from pensiones, income from interests and dividends. So we can use this information to take to have a full estimation of the incomes of the households.
Thank you so much, Francisco. That's extremely helpful. Okay, so let me follow up on that one. So you say the integrated survey, that's still the HEIH?
HEIH, yeah.
Okay, that's great. So you see, when I was talking before about census and asking income, can you just, for sharing the information with your colleagues, can you tell us how many questions do you have in HEIH in order to be able to measure income?
For income?
20?
20, 10? I think. 20.
So imagine if you wanted to measure income with that level of detail in the census, you would need to add 20 questions. That's a massive cost. So yeah, that's an interesting one. Thank you very much. And there is something else that I wanted to ask you also about the HEIH. Do you currently cover the whole country, or there are still areas of the country that HEIH doesn't go to?
There's still areas that HEIH don't go.
Like all national territories?
Yeah, for example, Amazonas, Putumayo, that we call new departments in the language of the survey. There is no data from these areas, and there is in this moment there is no exist poverty lines.
They don't have poverty lines either. Okay. So you measure the income from the HEIH. That's great. And in terms of the poverty lines, where are they built from?
NPH, I don't say in English, is National Survey from Presupuestos, from budgets.
Yes, okay. The budget survey. Yep, tell me.
And the last was in 2016 and 2017.
2016, 2017. Okay, great. And the HEIH, that goes?
That goes year by year.
Okay, and you publish results every month, every 3 months, every quarter?
Every month.
Every month, okay. Yeah, so that's the thing. I mean, I remember in the context of Latin America, Colombia actually has lots of data. That's really, really good. Okay, so that's great. That's in terms of income, the data sources that we were talking. Can anybody help me here? Census data, the last census, do you already have access? For example, if we were to use the census data together with survey data, is census data ready to be used now? Microdata has been released, or? From the last census in Colombia?
Yes, the team has the data, and the complete data set. We don't have the anonymized one. We have access to the identifiers and the whole questions in Census.
Okay, that's fantastic. And that is which year?
2018.
That's Census 2018. Okay, that's great. Now, in terms of administrative data, there was someone, Francisco, I think, who was talking to me a bit about administrative data. No, Jose was talking to me about administrative data. So administrative data that can help us, that includes something related to income right now that DANE has currently already kind of agreements in place and things like that. If you can give me a couple of names, just it would be good.
Yes, there are these administrative data that have distinct maturities, like in the sense we are not working with the all of the administrative data doesn't have like the same time in DANE of experience, como la misma madurez de su trabajo, pero en ese orden, in that order, we have worked with the PILA, Security Supplements, Familias en Acción, a Conditional Cash Transfer Program, Familias en Acción, Jóvenes en Acción, also a Conditional Transfer Programs, but addresses college students, and and these are we don't have the data available now, like the transformed administrative data, but I know that we have access to remesas, like I don't know how to say remesas in English, sorry.
Transfers, remesas, I guess.
Yeah,
like cash transfers from abroad, yeah. Okay. There is another name for that, but I don't remember. Yeah. Okay.
Yeah. There are other several cash transfer programs like Colombia Mayor for people older than 60 years old, and people in pensions, pension administrative data, and I don't know if anybody else remember another one.
Thank you so much, Jose. For this section that I'm talking about now, it's going to be this type of things are going to be less relevant. But when Nikos starts his part, then that's going to be extremely relevant to know which are the sources that you have and to find a way to combine them to produce the estimates. That's extremely helpful. PILA is just a second, Nikos. PILA is what is in PILA?
PILA is the main administrative sources for social security, for health, pensions, payments by the employers in Colombia, and we have like 50% of workers, of total Colombian workers in PILA, because we have low formality rates. And this is the main source for the statistical register I have mentioned.
Perfect. Thank you so much. Go on, Nikos.
Sorry to intervene here, but I think it's very relevant and important discussion. Two things I wanted to raise. One thing is basically to try and understand about relevant to the administrative data. At what level can this be linked to the survey data potentially? And if the linkage is possible, I may have missed that, or if the linkage is not possible, whether you could have some aggregates at some geographical levels that you could then use into potentially a model. Not for now, but potentially later on, it will be good to understand. And the same relevant to this is potentially the availability of geospatial information. Where effectively with geospatial information, we know that you cannot link it to households directly, because probably that will be very difficult. But what has happened in some countries is that they identify some geographical unit, which is very a fine grid of some form, and then they try to process the geospatial information at very small areas, and then they bring in the covariate information as a kind of contextual information into the model, but at a much lower level compared to the level of the target area, in your case, the municipality. And that might be a good way of both updating information in terms of not relying on the census so much, and also using unit level models, because for area level models, as we will see, the linkage of spatial information into the model is quite straightforward, but for unit level models it needs a bit more discussion. So how you process the data, the admin and geospatial data within DANE, it's a very relevant topic when we go to models later in this training. I'm going to stop here.
Thanks, Nikas. I don't know if we have anyone that has information about about what DIG is doing. I guess that would be the geographical division, right? Who's gonna go in? Okay, go on, Jose.
We, the team, like the participants of the course, we have been integrating unit level data and census, the household survey, and the administrative records using the identifier, the national identifier, when it is available. In the survey, not everybody has answered the question or answered it rightly, but in the administrative data we have better quality in national identifiers, and so we have been able to match to using a deterministic approach these sources. We sometimes it is necessary to recuperate or to join or to recuperate another type of document. We have several type documents, identifiers in Colombia: cédula, tarjeta de identidad, registro civil. So sometimes we recover a second type of document, so we can improve the match.
Okay, but in principle, you have access to individual level data, and the issue is how to match them with the survey, and rather than going all the way up to an area. That sounds.
Yes, we have been able to make those matches, so one of them have been published, but it is experimental. But this is experimental stage for the poverty measure.
Okay, that's great. Thank you so much. What about remote sensing data? Or no, wait a second. There was somebody. Paula wanted to jump in. Do you want to say something, Paula? Paula, I think Paula had to go because I don't see her in the. No, yeah, Paula's here in the chat. You wanted to add something, Paula? Not anymore. Okay. What about remote sensing data? Do you guys have any information about whether DANE has processed this type of data, satellite data, if anything like that is happening currently inside the office?
Yes, but not for monetary poverty, but for multidimensional poverty.
Okay.
So another group take the satellite image from Colombia to estimate the multidimensional poverty.
Okay. Okay, but that is data that has been produced in a way and maybe available also for other purposes.
Yeah.
Okay. Thank you so much, Francisco. Okay, this has been extremely helpful. So now let me, if anybody has any other comment or any question, otherwise I'm going to move to the next bit. Nope. Okay. So let me go back here. I was talking about two big things that we need to talk about when we talk about the small area problem. One of them, what are the data sources available and what were the advantages and disadvantages of each one of those data sources that we have available for estimation. And the second one may be something that people is less familiar with, which is the framework of inference. And depending on that, which potential estimators can you choose and how do you perform the uncertainty assessment? So let me go to talk about that. I mentioned that we have two main frameworks of inference for survey data. We could talk about design-based or model-assisted domain estimation, or we could talk about model-based small area estimation. What is the difference between those two? Well, the first one, design-based domain estimation, is basically the framework, is the standard framework that is being used whenever you have to do survey inference on the sampling surveys. That's the standard one. I'm not sure, I don't know how familiar you are with this framework of inference, but if you think about what the people of sampling in DIMPE is doing, that's what the guys of the equipos muestrales, or however it's called now, where the team of surveys in DIMPE is doing, that's what they do, design-based domain estimation. Now, it's a type of framework of inference that is quite different from everything else that happens in statistics. So if you come from an economics background, you may be more familiar with something like model-based estimation than you would be with design-based estimation. So what is the trick, the key question about design-based estimation? Design-based estimation basically assumes that the universe is given. Let's say Colombia has a certain number of population. Each one of the person that lives in Colombia has a set of variables that you would have like a vector. And if you were to be able to do a census, then you would have all the information that you need, and there will not be any need for any sort of statistical inference. That is what design-based estimation assumes. The population is fixed. The values of each one of the attributes of the individuals in that population are also fixed. If I had a census, there is no question. I wouldn't have any need for confidence intervals or variance estimation or anything like that. If I had a census, I would just sum and count. Another way to say that is to say that sampling is the primary source of randomness. The only problem that I have, the only reason why I need to use a statistical inference under this framework is because I don't have a census. Because what I have is a piece of that population that I observed through a survey. That is my main source of randomness, and that is everything that I'm going to use to generate any sort of statistical inference. So inference, things like expectation. What is the expected value of a particular estimator? What is the variance of a particular estimator? If I want to build a confidence interval, that are mainly probably the main things that we talk about when we talk about inference, only refer to the fact that I have a sample instead of having the whole population. So how do I make inference in that context? What I'm going to assume is that my population is fixed, that I selected a sample, and that the result that I observe in my sample is just one of many possible results that I could have observed if I had selected another sample. That is what the randomness comes from, just because of the sampling. So when you talk about expectation or variance, you talk about repeated sampling over the population. So imagine that you have the census data, you selected one sample, you get an estimate of poverty at national level, and that was 0.4. Now you select another sample, you get another estimate, and it's not 0.4, it's 0.38. And you get another sample and so on, and now you got 0.42. And it's the variability of those estimates due to the fact that you're observing different sets of units within the same population. Is that variability the only source of randomness in this case? Okay, the population values, the wise values in the population are unknown. I cannot see them all, but they're not random. I'm not assuming normal distributions here. I don't assume that Y has a normal or a Poisson distribution. There is no distributional assumptions whatsoever in the case of this inference. Okay, so this is a framework of inference that, as you can see, is quite different from everything that you see in your initial statistical courses. When you get your first statistical inference course, you talk about normal distribution, Poisson distribution, and you build confidence intervals based on asymptotic normality and things like that. That doesn't really happen in the case of design-based domain estimation, basically because Y is a variable just because I only see a piece of the population. If I could see it all, Y wouldn't be a variable at all. Okay? So this is a framework that is the standard. I said at the beginning, is the standard in the terms of dealing with survey information, in terms of survey sampling. This is the gold standard, not only in Colombia, but everywhere in the world. This is the gold standard framework for inference. Fundamentally because of the fact of being so flexible. You don't need to check that anybody is normal. You're not going to have a problem by assuming that Y is normal when actually it is not. There is very limited assumptions respect to this framework of inference. If all my randomness comes from the fact that I selected one subgroup of elements instead of another one, and I'm the one who decides how do I select them, I decide if I'm going to stratify, or I decide if I'm going to use simple random sampling, or I decide if I'm going to use a proportional to size sampling design, then in a way I have control of most of that. There are very limited assumptions because I am the one that controls how I observe the data. You see, it's not like when I say Y is normal and Y is in the population, I have no control over whether Y is normal or not, right? In this case, I do have control because I decide how I'm going to select those units. I don't have full control because life happens. So for example, people doesn't respond. So I may have control about the sampling design, but I don't have control over the non-response. Or because people makes mistakes when reporting the particular values of a variable. That is also something that is beyond my control. But in general, as a person that designs the sample, selects the sample, I have pretty much most control of what happens in terms of the inference. So that's why I say that this is a framework that makes very little assumptions because I am in control of the things that are happening. Now, that is in general what design-based estimation is about. Now, what about design-based estimation for domains? When I want now estimates not at the national level, but let's say at department levels or municipality levels or even lower levels than that. The response from the design-based perspective comes in two ways. One at the design stage and one at the estimation stage. And the response at the design stage is if you're interested on estimates at the, let's say, municipality level, then plan since the beginning for estimates at the municipality level. And how do we plan for that? Via basically sample size, allocation, and stratification. So for example, if you're interested on estimates at the municipality level, okay, the minimum that you need to ensure is that you have sample in every municipality, right? Because otherwise, how are you going to be able to produce an estimate if there is a municipality that didn't come up in your survey? So this is why you stratify. You make an allocation. You say, I'm going to go to every single municipality. And here, this is a small municipality. I need this amount of sample size. And in this other one, I need more. And in this one, I need less, and so on. But you plan. That's what I was mentioning before as plan domains. If you want to estimate 4 domains, then if possible, plan for those domains. That's what you do from this framework of inference in the design stage. And then later on, after the data has been collected, you selected your sample, the sample went to the field, people collected the questionnaires, you came back, you have all the information now, and you're going to do the estimation. Then you can use auxiliary data in the estimation process. And the main 2 tools that people use in that estimation stage for domains are a generalized regression estimation and calibration. Those are the main 2 tools that we're going to be using. I'm going to be describing those 2 a bit later on. But it's basically use information that most of the time that was collected within the same survey and maybe some external information, some external totals to try to produce an estimator that has a smaller variance than the estimator that doesn't use any auxiliary information. Okay, so a quick recap of that bit. Design-based domain estimation is the standard in survey sampling. It assumes the population is fixed, the values of Y are fixed. The only thing that creates all my problems is the fact that I cannot observe them all, but I can only observe a subset of them that I select in a sample. It is still the gold standard in terms of inference from sampling surveys. And for the estimation of domains, proposes basically 2 things. Plan for domains and use auxiliary information on the estimation stage. Okay? Are you familiar with this type of framework of inference? Have you done like calculation of estimates using this type of tools? Or that's something none of you works with? Have you ever used something like a calibration estimator, a generalized regression estimator, Horvitz-Thompson estimator? Any of those things ring a bell? Do any of those terms ring a bell for you? Nope. Okay. So I'm going to talk about this design-based framework for estimation for domains in most of this initial section. Okay, and that is, I'm not going to be able to give this is not a course on survey sampling, so I'm not going to be able to go through all the level of detail, but what I'm going to try to give you is a taste of how those things are calculated and why they're calculated the way they're calculated. Now, that's going to be useful because, as Nikos was saying, later on, inputs for some models, the inputs are actually estimates that come from this approach. Some of the inputs for model-based estimation comes from the design-based approach. So it's important to know how to calculate them and how to assess them. But also because much later on, when we talk about the framework, we are trying to see the process of a small error estimation as something where you don't have a problem and you jump directly to formulate a particular model, but rather something where you go in a sequential way, obtaining estimates so that it gives you tools to assess the quality of the estimates that you're going to produce at the end. And most of those initial estimates that you produce are design-based estimates. So it's important that you know how to obtain them and where they obtain the way they are. Okay? Then that is one of the frameworks for inference and survey data. The other framework is model-based small area estimation. And model-based estimation is much closer to anything that you have seen in your statistical courses. So in the case of model-based, we assume that the population values, the variable of income, for example, is a random realization of a superpopulation model. So there is a superpopulation model here that I'm calling Xi. Okay, and that superpopulation model generates a superpopulation Y. And then I see that population Y is that census population from the one that I sample. So you see, this is closer to like thinking on regression models, for example, where you have like a X's, betas, and Y responds to a model like that. And what you are actually seeing is one realization of a Y that has been generated in that way. So the model-based small area estimation approach, those have distributional assumptions, but more than distributional assumptions, it has model in the type of like regression model assumptions about how Y came to exist, let's say, whereas the design-based assume that Y is just given. There is no randomness about that. Now, there is an advantage of assuming that there is a model behind, because then we can use that model to do things like, for example, predicting Y for the cases where we don't see them. So let me give you a very quick example. In the case of income at the municipality level, okay? Imagine that I want to produce measures of average income for each one of the municipalities in Colombia. But my sampling design doesn't go to Florencia, Caquetá, like the HIH doesn't go to certain departments, for example, then I don't go to certain municipalities for whatever reason. If I go from the design-based domain estimation approach, I don't go there, I cannot do anything. Now, in the model-based small area estimation, I can say, okay, I didn't go there, but if I am happy to assume that income is the result of these other variables, I don't know, remote sensing things and other things, and the model that controls those things in Florencia, Caquetá is similar to that one in other municipalities that I observed, then I may be able to get an estimate for Florencia, Caquetá, which of course is valid up to the point that my assumption it is valid. So if my model is correct, that estimate makes sense. If my model is absolutely incorrect, then my estimate makes absolutely no sense. But at least I can provide an estimate. Okay, so that's the thing about model-based small area estimation. I'm going to assume that there is a model behind, and I'm going to use that model to predict the outcome variable for all those observations that I didn't see in my sample. The inference in this case may consider the randomness of the sampling design. But even if it doesn't consider the randomness of the sampling design, often it does. So you have like a two-stage things where you have a superpopulation model, that's one source of randomness, and then you have the sampling, that's the second source of randomness, and then you use inference that involves both things. Or you can use only the first one, only the superpopulation one. But whichever you decide to use, inference is conditional on the model that you're assuming. In the case of design-based estimation, it's pretty robust. You didn't need to assume a model, and you're still going to get estimates that have certain desirable characteristics, even if whatever you're doing is not right. In the case of model-based estimation, if your model is wrong, your inferences won't hold. Your inference is conditional on the validity of the model that you're assuming. So it's very important to check the assumptions of that model, okay? The model that we assume for Y, as you're going to see next week with Nikos, can be implicit, as in the case of synthetic estimators and composite estimators, where I don't really write a regression-like equation to describe how Y related with the X's, or it can be explicit, like in the case of the area or unit level models, where I can actually write what is the model that I'm using. Either way, we need to check the assumptions of the model that we're using. Questions up to here? Nope, nothing. Okay, so I'm just going to talk a little bit. I think I have these 3 slides, and then I'm going to break I'm going to make a break of 10 minutes. Okay, so this I already said it. Design-based inference, it is unfortunately an entity that is isolated from the mainstream of statistical inference. Statistical inference, when you talk about statistical inference, a basic course in statistics, what do you talk about? You talk about regression models, and you talk about distributions, normality, Poisson regression, blah, blah, blah. There are distributional assumptions, there is asymptotic inference, and so on. In that sense, design-based inference is like the weird guy that came to the party. It's completely separate from the mainstream of statistical inference. However, it is still the gold standard in terms of statistical inference for survey sampling. It is still the gold standard, and is still the gold standard for survey sampling in official statistics in particular. Now, it has some drawbacks that I'm going to try to describe later on, and some of those drawbacks are even more difficult to deal with in the case of small area estimation, in the case of estimation of domains. So let me go to some of those. The first one is, I mentioned that the response for whenever you want to do estimation for small domains, for let's say municipalities or even lower, is first thing you have to plan for that. And that sounds good, but it's not always possible. So for example, it's not always possible because it is too expensive, because you cannot really afford to go to all municipalities in a given country. Here in the UK, you have estimates at the level of postcode sometimes. It is unrealistic to presume that anybody is going to be able to go with the survey and collect data in every single postcode. So although you know that you're going to need estimates at that level, planning for those domains may be just unfeasible, for example, or because some of those domains are decided either ex post or are a secondary use of the information. So let's say you, with the HEIH, you collect data and you plan to release results at domains are your regions, and you make a very good planning, and you know that you want unemployment rates for the main cities. I don't know how many they are now, 20, whatever. So you design a sample that gives you accurate estimates monthly for each one of the main capital cities in the country. But then somebody else comes up and says, oh yeah, but I also want this other domain. And that was not taken into account in the sampling design. So some of those end up being unplanned just because they show up later to the party after the sample has been designed and after the sample has been selected. So it's not always possible to plan in advance for all the domains that are of interest. Also, because the use of auxiliary data is more restricted. So the gains that you can make in terms, for example, of precision may be small compared to the gains that you could do if you use model-based estimation. The situation is pretty straightforward. In the case of model-based estimation, you have the chance of assuming a model, and that gives you lots. Whereas in the case of design-based inference, you can, I'm going to show you how, you can assume a statistical model, but your assumptions are, you don't really do the jump. You stay kind of at the door. And by staying on the door, you don't really gain as much as you could have gained if you were happy to make the jump and then check your assumptions. So the gains that you obtain in the framework of design-based inference tend to be smaller. So if you're close to be able to provide estimates at a given level of geography, but your CVs are slightly higher, then maybe using design-based inference with the right information, auxiliary information, may put you in the right place. But if you're very, very far away, if you have CVs of 60%, 70%, and you want them 20%, then this is not likely to be enough, okay? There is another issue that is one that I find very interesting. So we talked about how the only source of randomness in the case of design-based estimation is the fact that I selected this sample or the other sample or the other sample. That's my only source of randomness. So that means that all the properties that I assess for any estimator are related to that is called repeated sampling. So for example, I can say that an estimator is unbiased under repeated sampling. What does that mean? Does that mean that whenever I select a sample, it gives me the right value? No, it doesn't. It just tells me that I select one sample, I get an estimate. I select another sample, I get another estimate. I select another sample, I get another estimate. And if I were to average all those different estimates, on average, I would recover the true value of the parameter. So that is the definition of unbiasedness in this particular context. Now, being unbiased in that case may be interesting from the theoretical point of view, but not really relevant from a practical point of view. Why? For example, if you have very small sample sizes, you may end up with estimates with areas of interest, municipalities that you wanted to produce an estimate for that are out of sample. So in other sample, you may have selected sample in this municipality if you have a different sample, but not this one. How is that useful for me in any way or form when now I have this sample and I need to produce estimates for this data set from this data set, and I don't have sample Influencia Caquetá? That is interesting from the theoretical point of view to know that in some samples I would have Florencia, in some samples I wouldn't have Florencia, but on average, I would get the right value for Florencia. But when I have only one sample, how useful can that be? So whenever I have very small sample sizes and out of sample areas, that's problematic. It's problematic, for example, if you have, I mentioned it earlier, a rare phenomenon. So if I'm trying to look for, let's say, disabled people that has very high education levels, that's going to be a very rare population. So I may select a sample, and after I finish selecting my sample, when I go to get an estimate of what is the income for that particular group of people, I have no one from that group of people. So is my estimate that they earn 0? No, I just didn't see them. So observed zeros are actually not true population zeros, but when I have only one sample, there's nothing I can do with that. More generally, it's not very useful to have an unbiased estimator, even if it's great the fact that on average I'm spot on, when that estimator has a very large variance. So let's say if my estimate for the average income in Florencia Caquetá is something that goes between 2,000 pesos and 5 million, and I only get to see one sample. From one sample, how good is to say, oh, on average, I would be spot on, but I just get one sample. What if I got a very bad one? If the variance is large, I'm going to have good samples and bad samples, and the one that I got could be anything, so it's kind of very risky to use this in the context of small domains. Now, that's a general problem, but in the case of small domains, all those things just cover even more importance because of those problems, because of out of sample areas, because of observed zeros, and because large variance may mean that the only guess that I have from the sample that I saw, it can be good, but it also can be very bad. Okay? Is this clear? Can anybody tell me anything? Because this is sort of key for you to understand. Nope. Okay. Now, what about model-based inference? Model-based inference is much closer to the body of mainstream statistical inference. However, it is not popular as design-based inference in the context of official statistics. Why? But what I was mentioning, because it makes assumptions, and sometimes we're uncomfortable making those assumptions. And traditionally, in the case of survey sampling, you can find discussions about model-based versus design-based that go back to the 1950s. Royal, Fred Smith, they go all back a very, very long time. This discussion has been open since at least 50, 60 years, 70 now. But the discussion has been always in the sense that the conclusion has been always in the sense that if I can do what I want to do, making less assumptions, why would I make more assumptions? Okay, so if you can get the estimates that you want without having to assume normality and without having to assume a model, and if you can get what you want, why would you make more assumptions if you don't really need to? So this is why design-based estimation stays there, and it remains there, and it hasn't been defeated in that sense. But there are particular problems like smaller estimation where it's just not enough. Okay. Now, in the case of model-based inference, you could use it also to do planning of a sampling design. There is also tools to do a sampling design, like before when we talk about stratification and sample size allocation, and you can also use model-based inference for that, but nobody does. That's very rare. Mainly, people use model-based inference for the analysis. After you have selected your sample, with your standard tools, just like if you were to use design-based inference, and probably you do use design-based inference for most stuff, you just use model-based for the little bit where design-based inference was not enough. So for example, the HEIH is designed under a traditional design-based framework of inference. The estimates for unemployment and the distribution of age and sex and the number of people in the room and rooms in the house and whatever, all those estimates at the levels for which the sample was designed, that region or the main capitals, or all those estimates are obtained using the traditional design-based methods. And we only talk about model-based inference for those domains where things just don't work out, when things don't work out in the standard setup. Now, by making, I mentioned we need to make assumptions. We need to assume some kind of model. Well, by making sensible assumptions about a model that generates the population of inference, we are in a situation where we can deploy a whole set of tools from the standard statistical inference, the things that you learned in all the other courses about regression and blues and all these kind of things that would be otherwise unavailable. And that is going to be something that is going to save the day when we talk about very small sample sizes. It also has much more flexibility to use several data sources. We're going to see, you're going to see with Nikos in the next week. There is no need for the domains to be planned in advance, but there is a gain if they can be. So it's not like you just give up and I worry about that in the estimation stage. No, if you can do something in the design stage, of course, please do. But even if you didn't, even if there were domains that shown up later, then you can still use this type of techniques. Performance, in any case, is going to be dependent on the quality of the data that you have available. If you have very limited data available, then nothing is going to perform a miracle. This is not going to be a miracle, but if you have good data, if you have, let's say, unit level data, if the data is quite correlated with the outcome that you're interested in measuring, then you may have interesting gains. And finally, again, the inference is no longer assumption-free, is nowhere near as assumption-free as the design-based inference is, but is conditional on the model. So now checking that a model, that model actually fits the population in an appropriate way becomes of paramount importance for you to make sure that your inferences are valid. Okay, so I have introduced those two. Different frameworks of inference, and I have sort of compared them a little bit. Now I'm going to talk for a moment about the small area problem, and then I make the break so that we can all have a glass of water or a coffee. So let me go back to the small area problem. We have an increasing interest on producing highly disaggregated estimates of demographic, social, economic indicators. Everybody wants to produce poverty estimates at the lowest possible level of resolution if you can. And estimation of small domains using only the standard survey sampling tools. The design-based inference may be problematic. I already say that, because not all of the domains can be planned, and even if they are, the sample sizes may be too small to produce accurate estimates at every single one of the domains, for example, due to costs. Because you can use auxiliary data in the analysis stage, and that can help you increase the precision of estimators, but it's still rather limited in scope. So the gains that you may obtain are going to be okay if you're close to make it, but if you're very far away, probably that's not going to be the thing that is going to work for you. And because some of the challenges of the relevance of this average behavior of a repeated sampling are particularly applicable to domain estimation, because it's not good for me to have an estimator that on average gives me the right value when I only have one sample and I saw no one. In that case, that's really not very practically useful. Besides this, in the case of small area problem, we have increasing availability of other data sources. People is talking more and more about administrative data, about remote sensing data, about using census data. We're in a time where not only in Colombia, but everywhere budgets are shrinking. So there is a real demand for looking for flexible solutions that make the best use of data. We don't want to have to go 3 times and ask 3 times with 3 different surveys the same thing to the same person, because it's costly and it's burdensome. So we are really encouraged to try to do the best that we can do to combine all those different data sources. The model-based approach is going to be very useful in that sense. And finally, well, making sensible assumptions, which is actually what we do everywhere else in statistic, but in survey sampling, may lead to better estimates. However, if you're happy to make those assumptions, then you need to make sure that those assumptions are properly verified. Okay? So that's all what I had to tell you about the small area problem and the 2 frameworks of inference, data sources as well. Now I have 2 examples where I'm going to present 2 cases, 2 study cases, and talk a little bit with you about those 2 study cases.